Welcome. This is the second part of my learning journey into learning TypeScript. I'm going to talk about concurrency. Yes, but before that, we need to go through some useful utilities. npm scripts. In package.json, you can define scripts such as test, where jest is run, or start, where it runs a server, which we'll define later. So we can run npm scripts by issuing the command npm run test or hello or whatever, and there's a shortcut for test, npm t, and a shortcut for starting a server, npm start. We also need to talk about error handling. It's inspired by Java. It's actually in JavaScript. So we can try something that can fail. If it fails, if it throws an exception, the exception is captured in the variable e. It can be any name, usually err or error. And in this case, all I'm doing is logging the exception. The finally block is optional, but if it is present, it will always be executed. That's why it says always executed. So let's look at the number operation that can fail. That's the function. Ideally, we do a check for the input here. But in this case, I'm relying on math square root to return not a number if we enter a bad input, like negative number. We can't do a square root of negative number. And if it is a bad input, we will throw a new exception or a new error with a message saying can't accept this number. Let's execute this. Now npm xtsc compiles all TypeScript files into JavaScript. We'll talk about that in a second when it completes. It's now complete. So it's created a javascript.js file, and I'll use node to execute that. And we can see, because we passed -2 into the square root function, it says number operation failed, cannot accept 2. And as we can also see, the always executed finally block is always executed. So when npx tsc is run without arguments, it falls back on a tsconfig JSON file to tell it what to do. So here the compiler options are please use library ES 2015 and the DOM library. ES 2015 is also known as ES6, but this is the more modern name. We will need the ES6 or ES 2015 library when we use promises with async and await, async functions. So now let's dive into concurrency. We can run a function in a non-blocking way. Get_a_num is run non-blockingly or run asynchronously. But before we go into that, let's look at this code. It starts by saying speaking, and 1 second later, it calls the speak function which says spoken. So if we ignore get a number for the time being, this whole process should take about 1 second. So get_a_num is an asynchronous function. Asynchronous functions always return promises. In this case, it returns a promise of type void. And no, it is not an empty promise. It's a promise to do something, but that something doesn't involve returning a value. As we can see here, get_a_num is waiting for promise number to give it a number because it promised to give it a number. And once it gave it a number, it can assign it to variable n and print out the value. So let's look at the promise number function. It's a normal function, it's not an asynchronous function. But what it does, it returns a promise of type number. This, when I first looked at it, was quite confusing. So let me focus on this for the time being. A new promise is created by saying promise resolve. Now there's nothing special about the word resolve, which is why I purposely chose the letter R. So when the promise is going to be fulfilled after 1 second, set timeout says please run this function, resolve to give a 1 to the promise. So the promise fulfills by returning the number 1, which is a number, which is good. Let's look at the whole main program now in its entirety. We have get a number, promise number, and speak. So if we run this code, we should expect it to take about 1 second and not 2 seconds, because this is run asynchronously. Now because I've run npx_tsc, it has compiled all the code. I can just run this lower part here, just to run the JavaScript that has already been compiled. That will save us some time. And yes, it took slightly above 1 second and not 2 seconds. That proves that it's run asynchronously. I want to speak about async functions and the lack of locking or mutexes. Async functions are very much like Go routines. So when you call an async function, they start immediately and they will not block the main program. Async functions end when what they promise to do is fulfilled or resolved. Now, TypeScript or JavaScript does not have a standard library for mutual exclusion, mutex, semaphores, or anything like the equivalent of Go channels for communication. These have to be coded by you or by me in this case. No discussion on concurrency is complete without exploring a web server. So let's install a very popular web server called Express. That's how it's installed, and we'll make a folder or directory to hold the server code. So this is the server code. We import the Express library and we create a new constant and point it to an instance of the server. Here, when we get the root, it runs the function which says send hello world. And at this point, the server will listen to port 3000 TCP and say to the log, the server is up and running, listening on port 3000. Now this is a non-blocking operation because we will see this showing up when we run it. So let's run the server. And the server is running. Let's prove that the server is running. Well, I think I can do this. Okay. Port 3000 and hello world shows up. I benchmarked the Express server with a concurrency level of 8. My laptop has 4 cores, so I'm overloading it quite a bit, and it could manage about 2000 requests per second, with the longest request taking about 15 milliseconds. As usual, if you want to download the code to this presentation, as well as the code samples written in TypeScript, this is my Git repository on GitHub. I am Siu Yin and I work for Zendit.